Thanks, Brett. Hopefully everyone's seeing the presentation slides, not the presenter mode. Is that true?
True, it looks good. Thank you.
Okay, awesome. All right, so I'll go ahead and give a little kind of a summary of the Bulletin 120 and just kind of forecast summary. I wanted to kind of spend the time to kind of peel back the curtain and kind of talk how it's kind of put together. It's been a while since we've talked about, what it takes to kind of put it together, what goes into it, and kind of that whole process. So kind of give everyone a little sneak peek of what it takes, what it is, in fact, kind of clear up some of those uncertainties. So for those not familiar with the Bulletin 120, it's published monthly starting in February. So it's actually published in February, March, April, and May for conditions as of the first of that month. And then actually gets updated weekly every single week after that until about the first or second week of June, kind of depending on conditions, depending on how dry or how wet that current year is. So I want to say this year we actually forecasted to the first week of June. There are years where we've actually forecasted, April through July runoff through, I want to say that first week of July. The main product that you're getting out of the Bulletin 120, of course, is the April through July runoff, as well as like the water year runoff, which is a statistical model. So you're getting basically a 90%, 50%, and 10% runoff exceedance, forecast exceedance, I should say. And so, historically, it was always kind of sent out as like this actual bulletin that you kind of see here. And so these actually still get printed and mailed out, and this is how the information was historically disseminated. And so these forecasts date back to about 1930. So we have a nice long record of forecasts. Nowadays, they're shown and portrayed in various different products on CDEC that we have. For example, we have what the monthly distribution is of the median forecast for all these watersheds, actually what the forecast summary is. So you're looking at our 90, 10, and 50% exceedance forecast for April through July. And then also what it looks like here with those weekly updates. And one cool thing about these now is that all of our forecast data is posted onto CDEC. And so you can actually use those date selectors where you can actually select a certain date and go back in time to see what the forecast was on a certain date. That's a new thing that we actually just implemented this past year. It used to just be a static text file where we just would upload it, and that is what it is. So big improvement that we've been able to do just by doing that. I should mention that the Bulletin 120, it is a forecast for about 24 different watersheds throughout the state. Basically, the upper watershed of the Sacramento Basin all the way down through the Kern, as well as kind of the North Lahontan region. We get a lot of confusion. What's the difference between Bulletin 120, Bulletin 120 update, the water supply index, the WSI, like what are you actually getting? So I actually briefly made this table here showing what do you get for each of this forecast. What are you getting on a Bulletin 120 that comes out on the first of the month? What are you getting on a Bulletin 120 that comes out for these weekly updates? What are you getting on these WSI forecasts? So, and then also roughly a calendar of when those get issued throughout the water year. So this little scale here on the bottom here is kind of the release of the forecast. So this is actually what it was for this past water year 2021. The first WSI forecast we release is conditions as of December 1st. And then we do that for December, January, December, January, February, March, April, and May. So we have six different WSI forecasts that we're doing every single year. And then like I had mentioned before, the Bulletin 120 doesn't start until February 1st. One of the big differences between the Bulletin 120 and WSI, aside from all these other forecasts that you're getting, is that the December and January WSI forecasts do not incorporate any type of snow data. That doesn't happen until the February 1st WSI, when snow data is then inserted into the Bulletin 120 forecast. And then from there, in turn, the Bulletin 120 is plugged into the WSI forecast. So the WSI doesn't usually see or doesn't see any type of snow data until February 1st. That's one of the big differences. Like I had mentioned before, the Bulletin 120 first of month forecast, those are issued typically on the 6th business day of the month, just because it takes a decent amount of time to gather a lot of that manually recorded data. And then the weekly updates are usually for conditions as of Tuesday of that week, and then issued 2 days later on that Thursday. I have little asterisks here for some of these forecasts, mainly because those are more unofficial forecasts where there isn't too much new data that's put into the model for some of these separated out watersheds, but just want to kind of caveat that. We put together a Bulletin 120 using what we call our water supply forecast tool. It is a web-based tool that we all log into from anywhere. This is a big move that we've moved away from Excel spreadsheets, and we've now moved it into this online web interface. There was hopes of eventually getting other people, even external parties, access to this to see what you can almost get a sneak peek into the forecast while we're doing it. Obviously, there's a lot of privileges, that we have versus what someone else may have, but this is the main tool that we're using to, basically collect the data, process it, post the forecast to CDEC and everything like that. So now kind of stepping back and peeling back the curtain here. So the forecasting procedures, they're statistical models. So they're based on multiple linear regression, and the variables that we introduce into it are a high elevation snow index, low elevation snow index, a lumped precipitation parameter. So it's an October through March precipitation index, another lumped precipitation index for the April through June period. And then for runoff, we're introducing an October through March runoff. And then for an antecedent conditions, we're looking at the prior year's April through July runoff. One big thing with the snow is that we actually only incorporate snow data from February 1st up until about April 1st. And with these multiple linear regression equations, it assumes peak snowpack occurs on April 1. So that is one of the big issues where obviously it could peak prior to that or after that. And so that's where we start to see a lot of the forecasts divert from reality. I will say we do have upwards of 5, 6, 7 different statistical models for each of the watersheds that we do forecast. We're actually working on a brand new one. We've finished off all the watersheds with the exception of the Feather and Kings watersheds as of this morning. So, just the general form of what our water supply forecast equations look like, right? We have some kind of coefficients in front of all of these different variables: high snow, low snow, October, March precip, and so on. So just kind of wanted to put this out there. Don't worry too much about this. I'm going to walk through an example of how we actually calculate these precip indices or snow indices. It's probably just easier to kind of walk through to see what the actual input is into the model based off of station data, and then introduce this whole indexing method. So this is basically the type of data that we're looking at here. And there's a lot of numbers here, but I can try to walk through as quickly as I can on this. So looking at this little table here up top, what we're looking at is the precipitation index for the May 1st forecast for the Feather River watershed. We know that because obviously there's no observed monthly precip for May, and here's the precip data for April. So like I said before, we have that October through March precipitation index. And so since we've already gone through that period, that is now locked in. And now we are calculating this April through June precipitation index. Starting off to the left, you can see the different precipitation stations that we're actually using in this indexing method. And we'll actually do this example here for Sierraville. So for example here, we have this basic kind of formula here where what we're doing is we're taking the observed April precipitation and then normalizing that by that period's average, so that April through June average. We normalize that and then we multiply that by some type of scaling factor based on the time of year. You can almost think of this as like a contribution to the April through July runoff. Similar here, you see like in October, that scale factor is only 0.5. You wouldn't expect too much of that precip in October to affect what happens to the April through July runoff. And then multiply that by 100. So for the example here, the precip index for the Sierraville station would be 64.7, which is what's calculated there. We do that for a variety of stations for that watershed, and then basically average that out across all those stations, and you get some type of number there. That's basically what 84.4 is for the basin-wide precip index for April. But what we use to predict future conditions is, I'll talk a little about it later on in the presentation, but it's this concept of median conditions. So we use median precipitation and median snow for future conditions for our forecast. So, right, if we're on April 1, we still need to know what kind of precip's going to be falling in May and June. What we're using is that median precip for May and June. So what we're doing is we're taking that April precipitation index, adding on what a median May would be, and then a median June. And then we would get basically what our April through that's actually a typo, April through June precipitation index, which would be this 117.4. And this 117.4 is the input into any of those multiple linear regression models we have, 1 through 6 or 7 different models that we have. Kind of moving on down towards moving to the snow indices and how those are calculated. The snow's easier and harder to kind of QC and incorporate into our models. This is just a simple correlation of our high snow elevation index to observed April through July runoff for the Kings and the Feather. So obviously, the Kings has a lot tighter and a better fit statistically compared to the Feather. Obviously we all know the Kings is a lot higher watershed, and it's a snow-driven watershed, whereas the Feather not so much. It's not as good of a predictor, but it's definitely one of the best predictors we have for April through July runoff. Some of the adjustments that we make to the snow course data that when it comes in is, well, first off, those snow courses are measured 4 times a year, traditionally 4 times a year in February, March, April, and May. And it's kind of centered, I shouldn't say centered, but focused around the first of the month for those months. We use a 10-day measurement window for safety reasons, and you can't really get out there on certain days. So we use that 10-day measurement window focused around that first of the month. So it'd be 7 days prior to the first of the month, and then up to the 3rd day of that month. And then also we make adjustments to the snow index calculations based on any type of precip that may have fallen after the snow course measurement was taken to get to the first of the month conditions, and then also vice versa if it was measured after the first. So that's actually what we call our intervening precipitation. And so this is the example here where, for example, the snow course was measured on March 29th, and say the SWE was measured at 10 inches. But what we use for our forecast is an April 1 condition, not necessarily what happened on March 29th. So what we do is we add in, if there was any kind of storm events between that time, in this example, fell on March 31st, we'll actually just add these two together and have some type of adjustment to get to an April 1 condition. And then on the flip side, same thing, if you measured a course on, say, April 3rd, but a lot of that actually maybe fell the day before on April 2nd. We will actually subtract out that amount to get an April 1 condition. Looking at the calculations for the high snow elevation index, it's similar to how the precipitation indices are also calculated, but with a different type, with the intervening precip component. So if you looked at this example, say for Bighorn, this is on the Kings River for the April 1 forecast this past year. Basically what happened here is what we're doing is we're taking what was actually observed water content from that snow course measurement, so 11 inches right there. And this was actually measured on March 25th. Looks like no snow actually fell between March 25th and April 1st, so the intervening precip would be 0. There is some type of factor that we have a ratio of for that station to the intervening precipitation that we do use, but in this case, there was no intervening precip. So basically, we would just say about 11 inches of SWE on the 1st. Again, we then normalize that by the April 1 average and then get a 49.2 snow index for just the Bighorn snow course. Those are then averaged across all the different snow courses used for the Kings River, and you get a 45.4 snow index. It's very close. It's not quite exact, but it would almost be considered like a percentage. So since it is all normalized. A little bit more about the median conditions here. I guess I already introduced it here, but this is one of the charts I kind of like to show here, where it kind of shows the different variables that we use in the Bulletin 120, and what we know and what we don't know up at a certain point. So on a February 1st forecast, we already know what's happened between October and through the end of January, but we're predicting median conditions for high, low snow, and then October, March precip, April through June precip. So thing is that these aren't going to change. These are basically locked in until you get into that period for the April through June scenario. For runoff, we don't use median conditions because it's a continuous variable and we can easily just estimate that out. Moving to a March 1 forecast, we know a little bit more pieces to the puzzle. So then that's, now we have observed conditions and there isn't as much median conditions here observed. By the time we get to April 1, we know all of this, but then really the only input into our forecast at this point is the April through June precip. That's the only thing going into our models after April 1. And then this is where we start to deviate from the models for various reasons. And there's a lot more model uncertainty and of course, weather uncertainty introduced into the model at this point. And this is when we start really analyzing the numbers as much as we can. I wanted to put all these links out there, and that way everyone knows where you can find all the Bulletin 120 links on CDEC, quite a few of our Tableau dashboards that we've put out there that are more interactive. We're trying to move more towards interactive charts that we can use. And that's basically all I had.